We're talking about some exponent laws and exponential equations. You should know these laws. In theory, you should have practiced a little bit with them in grade 9. What happens in grade 9 is you only talk about the exponential laws with numbers. So you do things like 3 squared times 3 cubed, that kind of stuff. With this, now we're going to include variables. But the rules are the same. So we're just going to review them. All right, the first rule that you probably know is that when you're multiplying two bases that are the same, you add the exponents. Okay, so some examples. This one you would be familiar with is 2 to the 4 times 2 to the 6. You've seen that one before, probably in grade 9. This is what we're talking about in grade 9. This is new because we have bases that are variables, but you do the same thing. So 3 plus 8 is 11. And here it gets a little more complicated because there's actually two different variables. All right, so x squared times x cubed, we add those and get 5. And then y to the 1 plus y to the 4 gives me y to the 5. So when you have more than one variable, you look at the common base. So you have to look at the bases that are the same in the x and then the bases that are the same in the y. But that's a rule you should know. Same thing with the quotient rule. When you're dividing, you subtract. Okay, and again, this one's probably familiar. 5 minus 3 is 2. If you have a variable, you do the same thing. 5 minus 2 is 3. And if you have more than one variable, you look at them separately. So you kind of look at the x's, and you go 2 minus 1 is 1. And then you look at the y's, and you have 5 minus 3 is 2. So that's the product rule and the quotient rule. The zero exponent rule, I'm not sure if you would have talked about this in grade 9 or not. I think you did. But x to the 0 is 1. Anything, any base, it doesn't matter what it is, to the 0 is 1, unless it's 0. 0 to the 0 is not 1. But you won't talk about 0 to the 0 until you get to grade 12. So y to the 0, 6 to the 0, this whole thing to the 0, it doesn't matter what's there, as long as it's not 0 in here, which it isn't, then they're all equal to 1. So that's a pretty easy rule to remember. Any base except 0 raised to the 0 is 1. Okay? And then the power rule, this is the other one you should know from before, that if you're raising a base or a power to another power, you multiply them. Okay? What is something you're used to, again, is probably something like this. You've seen this before. Okay? 3 to the 2 to the 4. You go 2 times 4 and get 8. If you have it with x, it's the same thing. 3 times 2 is 6, and the same thing with z. 5 times 2 is 10. Okay? The only thing that's a little bit interesting about this is if you have more than one variable. So let's say I have x cubed y squared, and the whole thing is raised to the 5th, and let's put a 3 in there as well. Okay? What you have to do with this is each of these gets multiplied by the 5, each of the exponents. So it's 3 to the 5th, x to the 15th, 3 times 5, and y to the 10th, 2 times 5. Okay? So that's the difference, is that it actually requires you to apply it to more than one thing. But it works for any power. Okay? So those are the rules that you probably are familiar with. The expanded power rule, again, I just showed you this, but if you have something where you're going further than just a single base, you have to apply each of the powers. So 2 cubed and a cubed, or 6 squared and x to the 3 squared. And it's the same thing with division. So if you're dividing and you have more than one term, so in other words, you have x squared divided by y, the x squared gets raised to the 4th power, and so does the y. Here you've actually got 3 different terms. Well, actually you got 4. You've got 2, you've got x, you've got the 3, and then you've got the y squared, and each one of them has to be cubed. So the 2 gets cubed and gives you 8, the x gets cubed and gives you x cubed, the 3 gets cubed and gives you 27, and then y squared cubed is 2 times 3 is 6. So hopefully that makes sense to you, because a lot of the questions you're going to be doing with these are actually combining more than one base. There's going to be a number of bases mixed together. Okay. Negative exponents, I'm not sure that you would have seen this before, but negative exponents, what you do is you just flip the base. Okay. So if you have a number that's raised to a variable that's raised to a negative exponent, you flip the base. So if x is raised to the minus m, it becomes 1 over x to the m. And then again here, if x to the minus m is in the denominator, it flips up to the numerator. So if you have a fraction like x over y, you just flip the base, y over x, and you change the exponent to a positive. All right, it's really important, though, you understand that a negative exponent is different than a negative down here. If I have minus 3 squared, okay, that is not 1/3 squared. That's not how that works, okay? And it's not the same thing even as 3 to the minus 2. These are also not the same, okay? That negative and that negative have nothing to do with each other. So it's important that you know that, all right? But a few examples of this, if you look, x to the minus 3, it's 1 over x cubed. 4 to the minus 2, you flip again, so it's 1 over 4 squared. Here, you'll notice, and this is what I'm talking about, that minus 4 stays on the top. It's not raised to a negative exponent. The x to the 5 is not raised to a negative exponent, so it stays in the numerator. This y gets flipped underneath and becomes y squared. Okay? So if you look here, same idea. This one, though, the negative's on the outside, the negative exponent's on the outside, so both things flip. So the y comes up, and the x squared goes down. All right, if you look at this one, it's because we're over here. The a is negative, so it goes at the bottom. The c is negative, so it flips up to the top, you'll notice. And the d is negative, so it flips up to the top. Okay, so that's the idea. There's other examples there, but that's the idea with the negative exponents. All right. And I've already mentioned this, but please understand that you know that. All right, that minus 3 is not the same thing as 1/3. Minus x is not the same thing as x to the minus 1. And then the only other thing to really be careful of is the negative. If you have a negative that's inside a set of parentheses, then when you square it or cube it or whatever you're doing to it, it's included in that power. So if it's minus 3 all squared, then that means minus 3 times minus 3. So you end up with 2 negatives, so it becomes positive. But if you have it written like this, where there's no parentheses, it's just minus and then 3 squared, the 3 squared becomes 9. The minus stays out front. Okay, and the reason is because you can think about this as minus 1 times 3 all squared. So that gives you minus 1 squared times 3 squared if you use your rules for exponents. Okay, here, this is minus 1 times 3 squared. And so that becomes minus 1 times 9. Okay, that's the difference. So there's a whole bunch of practice here, a whole bunch of them. Okay, and I'm not going to do all of these with you. I'm going to pick a few just to show you a couple of them, and then I'm going to let you practice on your own because there's also a whole nother set of practice questions here. Okay, and then you're actually going to have a series of handouts as well. So we're not going to go through all of these, but we'll just pick a few from each column. Here's one. This one's pretty easy. 3 times 4 cubed doesn't actually do anything except become 3 times 64. And that is 180 and 12, so 192. Okay. If we do this one, 2x cubed times 2x squared, that becomes 4. 2 times 2, and then x to the 5. You're adding exponents. This one looks kind of interesting. So what I like to do is, if I can, simplify first inside the bracket. So 5 divided by 20 is 1 and 5. X cubed divided by x is x squared. And y divided by y to the 5th is y to the 4th. Okay, over 4, or raised to the 4th. So that then becomes x squared to the 4th. That's x to the 8 divided by 5 to the 4th, which is 625. And then y to the 4th is y to the 16. And that would be my answer there. Okay. If we look over here at some of the more interesting ones, let's look at this one right here, number 38. Okay. What I'm going to do first, I see I have a c to the 0, that's 1, so I'm just going to get rid of that completely. And I'm going to leave it's a minus 2, so the very first thing I'm going to do is actually flip this fraction. Okay, and make it squared. Then I'm going to try to reduce as much as I can. The 3 over minus 2, those are not going to reduce. A squared over a cubed is going to leave me with an a on the bottom. B cubed over b squared is going to leave me with a b on the top, 3 minus 2. Okay, and then c to the 7th just stays on the top. And then I'm going to square the whole thing. So 3 squared becomes 9, b squared, and then c to the 14th. And it's divided by minus 2 squared, which is 4 times a squared. And that is my final answer. Okay. Now, I would encourage you to look at the notes and practice the other ones and see what you come up with. I don't see any there that are going to cause real big problems. If you look at something like this, you would have 2 to the 4th, okay, times f to the 4th times g to the 16th times f to the 6th times g to the 6th. Okay, if you kind of get rid of the brackets first, and then that 2 to the 4th is 16. F to the 4th times f to the 6th becomes f to the 10. You just add those exponents. And g to the 16th times g to the 6th becomes g to the 22nd. Okay, so there's another example. There are lots of them. If you look at the next set of sheets, we'll just look at this one, maybe 81 divided by, so we want to look at 81 divided by 2401, see if we can reduce that. Okay, and then this a to the 4th, b to the 4th, and c to the 12th doesn't reduce. So we look, and what we do is we look at, first of all, does 2401 divide evenly by 81? Okay, it does not. So then I try 2401 divided by 9, and it doesn't divide by 9. Then I divide it by 3, and I realize I can't reduce that either. Okay, but what this question's, if I take 81 and divide it by 2401, if I just take that and see what it is, it's not a nice number. You can see it's not even a repeating decimal, right? So we're just going to leave it as 84 over 2401. So there's actually nothing I can do to reduce this. So I can just leave it as is. Okay. Oh, sorry, those are the answers. That's why I can't reduce it. That's the answer to that one, the 37. That's my fault. Sorry, I didn't read that properly. So 9b squared c to the 14th over 4a squared, that happens to be the answer that I got here. So that's good. My apologies. I went through that question thinking I could do something like, wait a second, it doesn't reduce. That's why, because it's the answer. I need to read more carefully. So you have the practice. You also have the answer sheet. So that should help you get started on those, and I'm going to leave those for you to do.